Hey guys, how's it going? So my name's Defipancakes. I'm the CTO and co-founder of Titan Meta Aggregator. And I'm here to talk about LiteSVM and building a high-speed simulation layer. And we're building the simulation layer to optimize swap execution on Solana. So a bit about myself. I started in crypto in 2019. I started as a quantitative developer at a hedge fund called 162 Digital. There, I worked on various arbitrage and option strategies. In 2022, I got Solana pilled. Basically, I hopped on, started using Mango Markets and Drift, did all the funding rate arbitrage trades, and it decided that I wanted to build on Solana from there on out. So in 2022, I also joined Clone Protocol, which was a synthetic protocol, and I worked as their lead smart contract developer. Starting on Solana, building smart contracts, that's sort of where I learned the art of chewing glass and kind of got the reference on Twitter of what that really meant. And since then, I've always been in the hunt for new and better dev tooling, especially to test your smart contracts and verify the logic of what's going on. And that's kind of why I'm talking about LiteSVM today, because I'm just a big fan, and I'm going to try to shill you on it. OK, so I'm going to talk a little bit about what Titan is, and what we do there. So Titan's mission is premium trading experience on Solana. We do this by giving you the best and most accurate swap prices. We built our own custom proprietary routing algorithm called Talos. And Talos is able to provide the best prices 80% of the time. If we do not provide the best price on Talos, we fall back and we aggregate over Jupiter, Dflow, Pyth, Hashflow. That way, the users always get the best price. One of the issues that came about while we were building this product was actually simulating at scale. And I'll talk more about that in future slides. But this is where we kind of integrated LiteSVM into our application. OK, so what is LiteSVM? So LiteSVM is an in-process, fast, flexible Solana VM. Very simply, it lets you simulate Solana transactions locally. It's open source. It's written in Rust. It has JavaScript bindings. And it's actively developed and maintained by some really cracked Solana devs. Just to give you some code and a general workflow of how you'd use it. So first, you'd initialize LiteSVM. You'd load the various programs and accounts that you want to simulate with. And this is basically you defining your simulation universe. From there, you generate transactions that you want to simulate, and you'd process them through LiteSVM. Once you've processed them through, you can inspect the program logs. You can check the account state, balances, so on and so forth. Some more cool things about LiteSVM. You can basically play God in your environment. So you can skip the signature verification. You can raise the compute CU limits, change the compute budget, airdrop any amount of SOL that you want to any wallet. You can time travel between slots. Another really big one is you can write arbitrary data in the simulation. So for us at Titan, this is really important because we can actually simulate transactions with, let's say, $10 million USDC and swap it through Radium or Orca and check the results. This could also be really useful if you're building like a borrow-lend type protocol and you want to check what the parameter or configuration changes do. Other cool things are that you can overwrite any system variables that you want. So useful ones are like the clock or rent. So some similar direct comparisons to other tools that you may have currently been using or used in the past. I know for me, I started with the Solana test validator. This Solana test validator basically spins up a small mini Solana validator that you can test your transactions on. But this was kind of annoying to spin up a whole new process in order to test. Some other big problems with this as well is that the Solana test validator was quite slow. So as your code and as your test suite kind of grew, the time that it took for you to actually run your test suite would start to become quite painful. Solana program test is definitely a major improvement over Solana test validator in terms of speed. But unfortunately, it's also async and a bit clunky to use. And LiteSVM is non-async. It's really straightforward and simple, making it easier to integrate in your existing code. And since it has JS bindings, you don't need to know Rust in order to use it. LiteSVM also has huge speed gains over both the other tools, and the feature set for it is really complete. So going back to Titan and how we use LiteSVM in our system. So Titan pulls quotes from multiple different aggregators, but we did have one kind of problem with all of this, and that is how do we actually verify and compare these quotes? So number one, quotes from the aggregators may actually be from different slots. So that is like they're representing a quote from a different state of the blockchain. Number two, we want to verify these quotes and check that these aggregators or these other sources are not overquoting in order to provide the best price. And number three, overall, we wanted to minimize the slippage and improve the execution landing rate. For any swap product, that's the main thing you need to achieve is really high quality execution. So our first naive solution to this was to try to use RPC simulations. So there's an RPC call you can use called simulate transaction. And what we would do is every time we pulled quotes from all these different sources, we would run this simulation call, and we would run it over and over again to make sure that over time the user was seeing how these quotes actually changed over time. We ran into some major shortcomings. So one is the rate limit. We really couldn't scale out of that. Number two, in order for the quote to actually work, the user needed to actually have that user balance. So for example, if you were a user and you wanted to see how much Fartcoin cost for $1 million trade, you couldn't actually do that unless you had $1 million. And number three, you still couldn't actually guarantee that you were comparing all these quotes in the same slot just because of all the async. So we knew we needed something that could simulate routes at scale. And that also allowed a custom simulation environment. At this time, I had recently discovered LiteSVM, and although I knew it was still maturing, I did decide that it was the right tool for the job. And thus, we kind of built our own internal simulation service called LITES. It stands for LiteSVM Simulation Service. So just going to go over the quick architecture of how this works in our system. So the new workflow instead of the RPC, basically from the aggregators, we would collect all the quotes and all the transactions from them, and we would feed them into LITES. LITES would then actually pull all the required accounts from the same block in order to simulate them all. We would run simulations in parallel, so it was really fast, fractions of a second. And then we would stream the results downstream to the user, and then the user could continuously see the new best and updated prices. So what are the results of this? So the result is generally just a much smoother swap experience. Our landing rate is greater than 99.5%. The slippage is down to single digits, which we're really happy with. And we have live updating roughly every second. And we see this paired with Talos as being like a top-tier trading experience for the user. So kind of TLDR conclusion to end all of this. If you're a Solana dev doing simulations or thinking about doing simulations, please use LiteSVM. It's really cool. It's fast, flexible in process, and in general, it helped us build a better product, and I definitely think it's worth checking out. So if you want to check out Titan Exchange, I left some socials up there. I want to say big thanks to all the LiteSVM devs and maintainers, because you guys did a sick job, and thank you for listening.